Okay, good evening, everyone. I'll start with the class now. So today we are doing matrix and algebraic identity. So I'll start with matrix first, and then I'll go to algebraic identity. So I have merged two topics into it. Um, so I'm starting with definition of matrix. So matrix is something which is an ordered rectangular array of number or functions. So, what do I mean by this statement? So, try to understand. Uh, Let me go a little bit back into the history of evolution of matrix and why it was evolved. Actually, matrix was evolved when we were attempting to solve linear equations. We all know how to solve linear equation by substitution method or elimination method. So what is the other method of solving linear equation? So when there was an concept evolution of any other method to solve linear equation, matrix was found as a result of that. So suppose I tell you that, try to understand, suppose I tell you that uh, there is a person A who has 15 pens. How can you represent this particular information in terms of matrix? So you draw this square bracket and you write like this. If somebody has 15 pens and 5 notebooks, so these are number of pens and these are number of notebooks. So what happens is you write 15 here and 5 here. So this is how the information can be represented, and that is why I am telling that matrix is nothing but an ordered rectangular array of numbers. So this is how in an array a number or function is represented. The number or function, so each individual element over, so entries over here would be known as elements or entries. So whatever you enter over here, all these individuals are known as elements. You can also call it entries. Now, where is matrix used? Though this is none of this is not important from the board perspective, so it is used in cryptography and electronic spreadsheet. So matrix, I'll again repeat, is an ordered rectangular array. And when I say rectangular, it doesn't mean it will always be rectangular. When I discuss any type of matrix, you'll see square matrix are also there, and either it will be a square or rectangle. So this is how matrix is studied. I mean, this is the definition of matrix, which says that it is an ordered rectangular array of number or functions. And basically it was evolved to study or to solve simple linear equations, because we already had method, and while discussing any other method, this particular method was evolved. Now let me go to order of matrix. So try to understand what do I mean by order of matrix. So order of matrix is something like this. So matrix may have, so suppose how a matrix is represented. So a matrix is represented like this: A11, A12, this will not be there, A13, and likewise A1M or A21, A22, A23, and I'll keep this as N. This is A1N, this is A2N, and likewise I'll have AM1, AM2, AM3, and this will be AMN. So when somebody asks you to represent matrix in a very generalistic format, you can represent it like this. Now order of matrix as you can see it on over here, there are m rows over here. So 1 2 3 4, like m rows over here, and this is called column. So there are how many columns? There are n columns over here. So always remember, the first one to be used over here is number of rows, and the second one to be used over here is number of columns. So always remember this. There was a question which was given that in 3 into 4 kind of matrix, how many rows would be there? And I could see students making a lot of mistake in this. There were people who had written that there are 4 rows and not 3 rows. So always remember, the first one is number of rows and the second one is number of column. And a lot of people make mistake in this. I have seen myself while teaching that whenever this kind of question is given, like m into n or x into y, and how many number of rows, how many number of columns, people do make mistakes. So do have a clear cut conceptual clarity on this kind of questions, that first one is number of rows and second one is number of column. So the order of the matrix is number of, it is pronounced like this. So if it is m into n, so it is pronounced as m by n matrix, or m into n matrix. Or like here it is 3 by 2 matrix, 3 by 3 matrix, 2 by 3 matrix. So what does it tell? 2 by 3 matrix means it will have 2 rows, 1 2, and it will have 3 columns. Now how many number of elements would be there? Number of elements is equal to, so if I tell you how number of elements is equal to m into n. So total number of elements is equal to m into n. So which is number of rows into number of columns. So suppose I give you 3 by 2 matrix, 3 rows here and 2 columns here. So how many elements would be there? So a1, a2, a3, a4, a5, a6. Just by writing the matrix, you can see that there are 6 elements, which is equal to 3 into 2. So number of elements can be described by taking a number of rows and number of columns and then multiplying it all together. Now let me move to some other topic, which is an example over here. So consider that you have following information regarding number of men and number of women. How do you represent it in 3 into 2 matrix? So first of all, what it is telling you, it is saying you that you have to represent it in 3 into 2 matrix. So it means that there would be 3 columns, sorry, 3 rows. So I'm writing r1, r2, r3, and there would be 2 columns. So I'm writing c1 and c2, and I'm closing the bracket. I'm writing this is 3 into 2 matrix. Now what happens is, you have been given this particular information. So there are number of men worker are 30, number of women worker are 25 in first company. So I'm writing 30 men here and 25 women here. Then in second company there are 25 and 31, so I'm writing 25 and 31 here. And in the third company the number is 26 and 27 and 26, so I'm writing 27 and 26. And this is how you make it. This particular thing is just to understand you. You don't need to write it. You should only write that the matrix of number of workers for the given information would be equal to, and you should draw this particular matrix. So if you are drawing this particular matrix and you are giving this particular information, you will have clear cut understanding of what you have represented here, and you can get full marks for this. Now let me move to other topic, and there is also one or two question over here. So what I'm trying to do is that I am trying to uh, give you a question. So it is if a matrix has 8 elements, what are the possible orders it can have? So this question can be done by factorizing 8, because what happens is 8 has to be represented. Any matrix would be of order m into n. Now if and total elements is equal to number of rows into number of column, it means that total element is equal to 8, and I know that m into n is equal to 8. So what I'm doing, I'm breaking 8 into two parts, and by breaking 8 into two parts, I'm trying to gain numbers which can be represented as two numbers whose multiplication can be represented as 8. So what we can do over here is we can write like this, that m I can take as 1 and n I can take as 8. It means that there is only one row and there are 8 columns. So you can write numbers from a1 to a8 over here, and it'll be 1 into 8 matrix. Now simply you can reverse the order. So you can reverse the order and you can write matrix like this. So there would be 8 rows r1 to r2, and there can be only one column, so you can write numbers like a1 to a8. So this will be 8 into one type of matrix. So what I'm doing here is I've taken 1 8 and 8 1. Now you can take 2 and 4. So what I'm doing here is I'm making two rows and I'm making four columns, c1 c2 c3 c4, and I'm writing here, what I'm writing here is I'm writing a1 a2 a3 a4, and similarly a5 to a8. To change it, I can just swap the number of rows and columns. So I can make four rows here from r1 to r4, and I can make two columns here, c1 to c2. And what I can do is that I can write numbers from a1 to a4, and I can write numbers from a5 to a8. I'll have 8 columns. Apart from this, see, the number of elements can only be integers, so m and n can only be integers. So multiplication of two integers are 8. I can have only four possibilities like this. I cannot have more than these four possibilities. Why? Because if I need only integers, multiplication of two integers is 8. These are the only four possibilities. So first, second example, the answer is 1 8 8 1 4 8 and 2 4 and 4 2. So these are the four possibilities. Now let me go to the third question, and third question is primarily based on application of what we have studied till now. So it tells me that we have to construct a 3 into 2 matrix whose elements are like this. So what I'm doing over here is I'm finding out, I'm writing aij is equal to 1 by 2 I minus 3j. Now you understand the first I represents row and j represents column. Now to understand this question properly, it has been given that I have to construct 3 into 2 matrix. It means that number of rows has to be 3 and number of columns has to be 2. So what I'll do over here is I'll write A11, this will be A12, this will be A21, this will be A22, and this will be a31, this will be a32. Now value of I and j, when you write matrix like this, value of I and j is automatically available to you. Like in a11, I is equal to 1 and j is equal to 1. Now let's put the value over here, and this is the modulus sign, this is not the matrix sign. So what I do is I a11 comes out to be 1 by 2 1 minus 3 into 1, which gives me 1 by 2 1 minus 3, so which is 1 by 2 into 2, that comes out to be 1. So what I get over here is, if I draw the same thing over here, a11 comes out to be 1. Now let's find out a12. So to find out a12, what happens over here is that you get 1 by 2 1 minus 3 into 2, so this comes out to be 5 by 2. So I write here 5 by 2. This is not written, this uh, comma is not there. Now a21 would be equal to 1 by 2 2 minus 3 into 1, which is equal to 1 by 2 only, so I write this as 1 by 2. Now a22 would be equal to, you look at here, a22 would be equal to 1 by 2 uh, 2 minus 3 into 2, so this comes out to be 6, 2 minus 6, which is 4, so 1 by 2 into 4 will give me 2, so this will come out to be 2. Now let's go and find out a31. So this is 1 by 2 3 minus 3, so this comes out to be 0, so this is 0. And now I'll find out a32. So this is nothing but 1 by 2 3 minus 6, so this comes out to be 3 by 2, so this is 3 by 2. This is how you make matrix. So if somebody is giving you this kind of information and you have to form the matrix, the first thing that you need to do is form this generalized matrix, because until and unless you have this generalized matrix available to you, the value of I and j would not be identifiable to you. And once you identify value of I and j, there is nothing else to be done other than some multiplication and addition subtraction. So this making of this generalized matrix help in case of solving the question correctly. So even if you don't draw it, and I will suggest that if this kind of question comes in your copy, in your answer sheet, you draw this generalized matrix. Only drawing this generalized matrix will give you at least 1 marks. If it is a 3 marks question, it'll make sure you get 1 marks question by drawing this generalized matrix. What happens in case of matrix question is that most of the time we don't make generalized matrix, and due to that we tend to make a lot of mistake. So I always suggest that whenever you are attempting a matrix question, even if you don't draw this generalized matrix on the notebook or on the answer sheet, better you draw it in the rough sheet so that you have basic idea of what you are doing. Because if it has been given 3 into 2 matrix and you take 3 as column and 2 as row, anyway you tend to make that mistake, which you should not do. So time and again I'm focusing on the row and column thing, and now I'm telling you that this kind of generalized matrix has to be made in most of the questions that you solve for matrix. If generalized matrix is available to you, what happens is most of the time you get the right answer. Now let me go to type of matrix, and I have made different kind of matrix here. So first one is column matrix. Now what do I mean by column matrix? So by column matrix, I mean that the first one which I'm taking over here is column matrix. And by column matrix, I mean to say that column matrix is like this. Column matrix will have number of columns equal to 1. It means that if generalistic type of matrix I, or order of generalistic matrix I, represent by m into n, and if n is equal to 1, so if it becomes m into one type of matrix, it becomes column matrix, that only one column is available here. So you can write it that if somebody is asking you definition of column matrix, first you should write that the a matrix is said to be a column matrix if it has only one column. So this is the generalistic description. Now you go and explain your generalistic description by giving the order of a general matrix M into n, and you say that n has to be equal to 1, and if n is equal to 1, now the order of generalistic matrix become M into 1 in that case. And you can represent normally any matrix is represented in very short form like this, aij, where, and I write the matrix M into n. Now for column matrix, this matrix you can write like A is equal to element aij M into 1. If you write this, you will get the full marks. Somebody will understand that the person is understanding that the number of column has to be equal to 1, and he is doing that. So you will get the full marks for that. Now let me move to rom r- row matrix. So in case of row matrix, you might have understood by the name itself, row matrix is something where you have only one row. So if I have to define this, a matrix is said to be a row matrix if it has only one row. So now I have written this. Now I'll define it like any general matrix. I'll take a matrix is A11, A21, A31, and I'll keep on going till the time I write AM1. So what happens over, sorry, I have made a column matrix here. In case of row matrix, I'll write something like this. So I'll write A11, A12, A13 till the time I write A1n. What I'm trying to do over here, any generalistic matrix would be written like that, Aij M into n. If M is equal to 1, so it becomes a row matrix. So I'll write it as A is equal to Aij 1 into n. If you write it, you get full marks for this. Now let me go to square matrix. So just for the sake of definition, any square matrix. So let me write square matrix over here. So a matrix, if you should write like this, a matrix which has same number of rows and columns. So that would be a square matrix. What I'm trying to say is that you can make something like this. You can write A11, A12, and A21 and A22. So this is 2 into 2 matrix. What I'm trying to basically say is that in n into n, it becomes a square matrix when m becomes equal to m. So you can write like this, that any matrix A is Aij m into n, where m is equal to n, that matrix becomes your square matrix. Now let me go to rectangular matrix. So rectangular matrix means wherever m not equal to n. So if number of rows not equal to number of columns, so what do you get there? You get a rectangular matrix over there. So m is not equal to n. So I'm just writing like this, A is equal to Aij and m into n the order. So if m not equal to m, that is your rectangular matrix. Now let me go to diagonal matrix. What do you mean by diagonal matrix? So if in any square matrix, So first of all, diagonal matrix is a type of square matrix. So first there would be a square matrix, and in that there would be a diagonal matrix. So if in square matrix there is a diagonal matrix is something where elements are only available. Suppose I take 3 into 3 square matrix, and so what will happen is there would be three diagonal elements. This A11, suppose I am writing A12, A21, A A sorry A13, A21, A22, A23, A31, A32, A33. So this particular line is known as, not this one. You no, you should not take this opposite one. This particular line is known as diagonal, and A11, A22, and A33 will not be equal to 0. It means that Aij, where I is equal to j, would not be equal to 0, and Aij, where I is not equal to j, would be equal to 0. So let me make a diagonal matrix for you. I am writing 2 0 0 0 3 0 0 0 5. You look at here, the diagonals are not 0. All other elements apart from the diagonals are 0. So this is what the diagonal matrix is. Now let me move to scalar matrix. Now what do I mean by scalar matrix? So a scalar matrix is a type of diagonal matrix. So what does it mean? It scalar matrix is, I'm just explaining it. Scalar matrix is, so you should write definition like this. Scalar matrix is a type of diagonal matrix where the diagonal elements are zero. Sorry, equal. So diagonal elements are equal. So any matrix which you take, suppose I take any 2 into 2 matrix, so it will be minus 1 0 0 minus 1. Or I can take 3 into 3 matrix, so I will make this as 0. This is 3, this is 3, this is 3, and all others are 0. So if in a diagonal matrix the diagonal elements are equal, that comes out to be a scalar matrix. Now if you have to represent scalar matrix in generalistic term, you see here how I am doing it. Any matrix is represented by Aij m into n. So element I'll write where I is equal to j, elements are equal, and where I not equal to j, element I mean Aij would be equal to 0. So that is how you have to write this. Now let me move to identity matrix. So a square matrix in which elements in the diagonal are all 1 and rest all are 0 is known as identity matrix. So what I'm trying to say is that let's say a scalar matrix where diagonal terms are 1. So let's take a 2 by 2 matrix and look at here, diagonal term is 1. This is known as identity matrix. So this can be represented as identity matrix. Now let me go to zero matrix. Now zero matrix means all the elements are 0. So if all the elements of a matrix is 0, then that matrix would be known as zero matrix. So you can represent it in normal term Aij m into m, where you can write Aij is equal to 0, where I is from 1 to m and j is from 1 to n. So you can write like this, and you can say that this is zero matrix. So these were the type of matrix that exist here. Now let me move to another topic, and that topic is transpose of the matrix and equality of the matrix. So what do you mean by transpose of the matrix? Transpose of the matrix means that exchanging rows with columns. So suppose I'm taking a rectangular matrix. So suppose I have any matrix A as 2 3 5 and 4 2 1. So this is a 2 into 3 kind of matrix. Now if you exchange rows with columns, so this is your first row would be row 1 would be made column 1. So I'm writing column 1 here, and I'll write all the elements of row 1 exactly in the column 1. Similarly, this is row 2, so row 2 would be converted to column 2. So column 2, all the matrix I will write like this. Now you should see that you should not start from the right hand side, you should start from the left hand side. So matrix starts from here. So I'm starting from 2 and writing 2 3 5 in a vertical manner so that it comes into a column. And similarly, I'm taking 4 to 1 and writing it in a vertical manner in second column. So now what happens is, now number of rows becomes 2 and number of column becomes uh, number of rows becomes 3 and number of column becomes 2. So here m into n is there. If order of a matrix is m into n, for transpose matrix, order will change to n into m, because I'm swapping the number of rows and number of columns. So this is what I mean by transpose of a matrix. Now let me go to equality of a matrix, and I have written a few conditions in the PPT itself. That first of all, any matrix, or if two matrices to be equal, they have to be of same order. So I am writing a matrix A which has a order m into n, and a matrix B which has a order m into n, then only the two matrix A and B can be equal. If matrix B has x in, if of order x into y, and where x not equal to m and y not equal to n, or any one of them, then the matrix cannot be equal. So for matrix to be equal, it is very important, or the most important criteria is they are to be of same order. The second condition is each element of A is equal to corresponding element of B. So if I make something like this, A11, A12, and A1n, and likewise AM1, AM2, AMN, and I'm making it equal to B11, B12, B1n, and BM1, BM2, and BMN. So both the matrices are first of all m into n order. This is m into n order. This is m into n order. And now what I do is that if you have to make this to be equal, it means that Aij over here is equal to Bij. It means that corresponding terms are only equal, corresponding elements are only equal. So you take first row, element first row, first column. Here you have to take element first row, first column. Here you are taking element fifth row, fourth column, or here also you have to take element fifth row, fifth column. So it means that you cannot change that corresponding order of the element. It has to be same always. Now let me give solve a question over here. So the question can be taken as, suppose I'm talking about equality, so let me take a question of equality. And suppose I give you a question like this, where I talk about concept of equality. So I am taking a 3 by 3 matrix, and where I have to find out few terms. So I'm writing those terms here, and those terms are, suppose this is 3y minus 2, this is 2c plus 2, and this is 0. And I just close it. Now I'm asking what is x, y, z, a, b, c, whatever I have written here. So what I'll do is that this x plus 3, this is first row, first column, and these two matrices are equal. So x plus 3 would be equal to first row, first column of the second matrix. So I will write x plus 3 is equal to 0. I'll find that x is equal to minus 3. Now this z plus 4, which is first row, second column, would be equal to first row, second column of the second matrix. So I can write that z plus 4 is equal to 6, and I can say that z is equal to 6 minus 4, which is equal to 2, and 2y minus 7 is equal to 3y minus 2 here. So I can write that minus y is equal to minus 2 plus 7, which is equal to 5. So y will come out to be minus 5. Now let me go to a. So here I see that a minus 1 is equal to 3. Sorry, this is minus 3. So a is equal to minus 1, sorry, plus 1 minus 3, which comes out to be minus 2. Now I know that b minus 3 should be equal to 2b plus 4, because this is third row first column. I am comparing it with third row first column here. So I get b minus 2b is equal to 7. B comes out to be minus 7. Similarly, I can see here second row third column that 2c plus 2 is equal to 0. So c will come out to be minus 1. So that's how you have to solve this question. So you should always remember that in case of equality, the first and the most important condition is that they have to be of same order, and the second important condition is that when you are making the elements equal, the corresponding elements are only equal. It has to be taken care of always. Now let me move to addition operation on matrices. So I'm starting with addition and subtraction. So it's the same thing again. So if order is not same, addition and subtraction cannot be performed. And what do you add and subtract? You add and subtract corresponding elements from both the sides. So I have written over here there are two matrices, so I'm taking 2 into 3 matrix from 2 into 3 matrix A and B. So you see here first row first column is A11, and first row first column is A11 here. So if I am adding A and B, I am adding first row first column of both the matrix, so it comes out to be A11 plus B11. Now here it is A12 and B12, so I am adding here A12 plus B12, and this is A13 plus B13, so this is A13 plus B13. So what I am doing is I am adding corresponding elements over here from both the sides. Now here only I will teach you scalar product of matrix. So what do I mean by that, scalar product of matrix? So suppose I am writing a matrix, suppose I am writing a 2 into 2 matrix. So suppose A is equal to 3 5 minus 2 1, and I have to find out 2A. So what do I mean by 2A? I mean A plus A. So A plus A means 3, 5, minus 2, 1 plus 3, 5, minus 2, 1. So I add 3 plus 3, 6, 5 plus 5, 10, minus 2, minus 2, minus 4, 1 plus 1, 2. So actually I'm adding A 2 times. Rather than doing this, what I could have done that if A is multiplied by 2, so I could have multiplied each element with 2, I could have got the same answer. So multiply each element with 2. I am writing here, you will get 6, 10, minus 4 and 2. So a scalar product means whenever a matrix is multiplied by a constant, You multiply all the numbers, all the elements of the matrix with same constant. If a matrix is divided by a constant, you divide all the elements of the matrix with the same um, constant. So what happens over here is these kind of questions do appear in the examination. So while multiplying or dividing, do take care that you are multiplying and dividing carefully, because if it is a 3 into 3 or 4 into a 4 into 4 matrix, you have to divide or multiply nine elements or 16 elements. So it becomes I mean very calculation intensive, and sometimes we tend to make calculation mistakes which we should avoid. So always be prepared when this kind of scalar multiplication or division comes. Just take a little bit of caution while solving this, so that you can avoid calculation mistakes. Now let me move to another topic, which is multiplication of matrix. So what do I mean by or let's discuss the process of multiplication of matrix. So what happens, I have taken a 3 into 3 matrix here, and I have taken a 3 into 3 matrix here. So if I generalize it, I take A11, A12, A13, A21, A22, A23, A31, A32, A33 multiplied by B11, B12, B13, B21, B22, B23, and similarly 31, 32, and 33. Now multiplication method is pretty simple. You take first row and first column at the first time. So try to understand the order of the multiplication. What would be order of the multiplication? So I am writing here, if you have a matrix of m into n, and you have a matrix of n into p here, suppose. So if you multiply these two matrix, you find order of the matrix as m into p. So first thing that you need to understand is that this number of column here and number of row here has to be same. If it is not same, then what happens? So that I'll discuss later how it is done. First I'm taking this kind of multiplication. So see here, I have taken 3 into 3 kind of multiplication. So what I'm doing is, I am taking first row here and first column here. So I multiply A11 into B11, first term and first term. I take second term in the row and multiply second term in the column and add here. So A12 into B21, plus I take third row in the a third element in the row. So and here third element in the column, so A13 into B31. So this makes my first term of, or first element of the multiplication matrix. So now what I do for the second term, I keep the row here, change the column here. So now the second term would be, you look at here, I have taken A, the first term here, multiplied to the first term here, it becomes AJ, plus I take the second term here and second term in the column here, this becomes BM. I take the third term here and third term here, this becomes CP. Now what I have done over here for the second element is that this row remains same, but the column over here changes. So it becomes AK, first term here and first term in second column. So AK, for second term here and second term in the second column, so this becomes BN and this becomes CQ. Now again the row will remain same and the column will change. So this I'll keep on doing. So AL, BO and C are all added together. Now I'm finished with all the rows here. Now I'll go to second row here. I'll take second row again. I'll multiply first here with first column, second with second column, and third for third element with third column. Now I'm done with all the columns here. Now I'll go here. I take first element here, first element here, second element here, second element here, third element here, third element here. So it's actually row into column kind of multiplication is here in this case. So let me take a multiplication example and solve it for you guys. And I will also tell you, suppose A is 6923 and B is 260798. So if I have to multiply A into B, how will I do it? So you look at here, I take first term here, 6 into 2, plus I'll take second term here and I'll multiply to this 7. So this becomes 9 into 7. Now what I'll do, I'll take 6 here and multiply to second here. So 6 into 6 and plus 9 into 9. Then I'll take 6 into 0, so which becomes 0, and 9 into 8, which becomes 72. And I'll do the same thing here. I'm exhausted with all the columns here. Now I'm going to second row here, 2 into 2, plus I take the second number here and multiply it to this, 3 into 7. For then I'll go to second column, so second row into second column, so 2 into 6 plus 3 into 9. And then I go to second row into third column, so 0 into 2 is 0 and 3 into 8, so that becomes 24. So this is nothing but 6 into 2, 12, plus 9 into 7, 63. So 12 plus 63 here. I have 36 plus 81 here, and I have 72 here. Then I have 4 plus 21 here. I have 12 plus 27 here, and I have 24 here. So it gives me 75 here. It also gives me 117 here. This becomes 72. This becomes 25. This becomes 39, and this becomes 24. Now, let me come to order of the multiplication. Order of the multiplication is 2 into 3. Now what do I have here? Order of A is 2 into 2. Order of B is 2 into 3. Now I told you in the beginning itself that if you multiply 2 into 2 and 2 into 3, the column here and the row here vanish, and you get what you get as a result is 2 into 3. So if M into N is multiplied by N into P, what you do is this N gets vanished and the order of multiplication matrix would be M into P. So it can be easily asked to you that what kind of, I can give you a question that M into N and N into P kind of matrix is getting multiplied. What would be the order of resultant matrix? You should write M into P. So a 1 mark question can be there on this particular concept. So I have shown you how multiplication is done. Now what I'll do is I'll take a few properties of multiplication. So let me take a few properties of multiplication. So properties of multiplication, first one, it is non-commutative. So what do I mean by non-commutative? So non-commutative means A into B is not equal to B into A. So why does it happen? Because in case of, I had taken the example of suppose I take an example of this. So I take 1, -2, 3, and minus 4 to 5, this is my matrix A. And I take an example of B. You take 2 4 2 and 3 5 1. It gives me a matrix of 2 into 3, and this is 3 into 2. So A into B, just you take A into B is 2 into 2 matrix, because this 3 gets vanished as I just told you, and B into A would be, because this is 3 into 2 and this is 2 into 3, so this 2 gets vanished, this would be 3 into 3 matrix. So what happens is, here you have only 4 elements and here you have 9 elements. So you can see that A into B and B into A, you don't need to multiply over here and check, you can do so by, and if you do so you will get that kind of matrix. But just by taking the order of the matrix, I have told you that m into n multiplied by n into p, you get m into p kind of resultant matrix. So what happens over here is, if I multiply 2 into 3 to 3 into 2, 2 3 gets vanished, so you get 2 into 2 matrix, and here you get 3 into 3 matrix, 4 elements here, 9 elements here. So you cannot actually get the same matrix, so it is non-commutative in nature, and this is one of the most important properties of multiplication of matrices. So if you have this property in mind, you can avoid a few mistakes. The second, two three other properties that I would like to discuss is, the associative law holds over here. So if a matrix is like this, A into B and then multiplied to C, this can be equal to A, B and C multiplied first, and then it is getting multiplied. So associative law holds here. Then you can say that distributive law also holds here. So distributive law also holds here. So what do I mean by distributive law? So if this is the matrix A multiplied by B plus C, you can write this as AB plus AC. This will hold true. Or if you take it from the other side, so you can write A into B multiplied by C, you can write it AC plus BC. This also holds true. So this is what needs to be done. Now let me go to other properties of matrices. So these are few properties of matrices. You know when you can multiply the matrix, when you cannot multiply the matrix. I have already discussed transpose of the matrix and all those things with you. So matrix at class 10th level is only up to this level, where you have to do multiplications. You should know transpose and scalar multiplication, because there are many questions which comes on the basis of scalar multiplication. So if you know scalar multiplication, which I already discussed, and there is nothing in that scalar multiplication other than multiplying or dividing all the elements depending on the question over there by the constant given over there. So you can solve most of the questions using the concepts that I have already discussed with you. Now let me move to the other topic, which is algebraic expressions. Now, algebraic expression is a very important topic for autonomous Cbse board, and you can see very tricky questions which come from this topic. So what happens is, mostly the question based on algebraic expression is simplification of algebraic expression, which we call taking it into its simplest form. So most of the questions are based on finding the expression given in the simplest form. If that kind of question is not given, then there would be few addition, multiplication, subtraction, division kind of question where multiple expressions would be given. They would be mostly correlated to each other, and you will have to add, subtract, multiply, or divide those expressions. So generally it is best on that concept. So this is not a very difficult topic, but in rush of things, we sometimes we tend to make mistake, which I think is which I think that can be negated if we practice this kind of question a lot. So let me start with discussing properties of integer first, this topic. So first property of integer is pretty simple, and I'm writing all the properties here. First property is sum of any number of integers will always be integer, will always be equal to an integer. The second property is that associative law and commutative law. So I have already discussed associative law and commutative law. So commutative law is associative law is a plus b plus c, and I put it in the bracket, is equal to b plus c plus a. So this is your associative law, and commutative law tells me that a into b is equal to b into a. So associative law of multiplication all also true over here, and in addition also commutative law is true. So multiplication is a into b multiplied by c is a into b into c, that is also true. So these are the few properties, so all the properties hold true over here. Now let me go to properties of polynomials. Now, what is properties of polynomials? So I will finish it in only 2-3 sentences. So any polynomial is first represented by px or qx. It shows a polynomial in terms of x. Now I'm just saying, I'm making a statement which is why these two things has been given together, because most of the properties matches with each other. So I told that some of the two integers are always integer. Here I'm saying that some of the two or more polynomial will always be a polynomial. So here also associative law of addition and multiplication, commutative law, distributive law, all the laws that we have discussed will hold true for polynomial also. So if we have these things in mind, we can negotiate between the problems easily. Now we all know it, so there is not much emphasis needed on this topic. Now let me go to another topic, which is this. So analogy between rational number and rational expressions. So what is a rational number? Any rational number can be written as m by n. Similarly, a rational expression can also be written as px by qx. Now we all know that this n should not be equal to 0. Here also qx should not be equal to 0. Now here also rational numbers and rational expression follow laws of, in case of both addition and multiplication, it follows law of or I can say associative law, distributive law, and commutative law. So all these laws are followed by rational numbers and rational expressions both. So now let me move to rational expressions properly. Now, algebraic expressions are basically study of rational expressions, and any rational expression is represented by px divided by qx, where qx is not equal to 0. Now this px by qx need not to be a polynomial. You can say that qx can be equal to 1 also here. Now take an example here. So suppose I have an example 3x minus 4 divided by 5x square plus 2x plus 3. Now if somebody asks you whether this is a rational expression or not, so what will I say? I'll say that this is a rational expression, because if I compare px is a linear equation, and if I compare qx is a quadratic equation. So px by qx has to be a rational expression. Let me take another example for you. If I take this example, 5x to the power 4 3x root 3x cube plus 2x square minus 5 divided by 3x cube minus root 2x square minus 9. So if somebody asks me whether this is rational expression or not, if I compare px is a biquadratic equation and qx is a cubic equation. So px by qx is a rational equation. But what about this which I'm going to write? I'm going to write this equation for you: x cube plus 5x square minus 3 divided by x square plus root x plus 1. Now this polynomial is okay, but what about qx? Qx is not a rational polynomial, because here the power is not an integer, it is a square root which has been involved here. And wherever in variable integer is not there, the variable or like x to the power integer is not there, those kind of situations we will call that the expression is not a rational expression. So here, as power of x is not integer, it is 1 by 2, I'll say that this is not a rational expression. So that is how we have to identify which expression is a rational expression and which expression is not a rational expression. When you are when you are looking at any algebraic expression, you have to look that in both numerator and denominator what happens is the power of x has to be an integer. If it is a square root, cube root, or any other root 1 to the power n kind of thing, it cannot be a rational expression. Now let me discuss something else, which is rational expression in lowest form. Now how do you find any rational expression is in lowest form or not? So there is a very basic rule about finding any rational expression in lowest form. And what is it? So you take any number. Suppose you take a expression like this: x minus 3 x plus 5 divided by x minus 5. Now, is this in lowest form or not? Or let me take another number, 3 divided by 7. Whether this is in lowest form or not. Let me take a number 2 divided by 6. Whether it is in lowest form or not. What do we do to check any particular rational expression or rational number is in lowest form or not? So we take numerator and we take denominator and we try to find out HCF of numerator and denominator. So greatest common denominator or HCF of numerator and denominator is should be 1. If If HCF of numerator and denominator is 1, it means that there is no common factor between numerator and denominator. So though that common factor cannot be cancelled out, the common factor is 1. So you see here there is no common term between x minus 3, x plus 5 and x minus 5. Hence, the HCF over here is nothing but that is equal to 1. 3 and 7 also HCF is 1, but 2 and 6 HCF is not 1. So this is not it in its simplest term. So I know 2 and 6 HCF is 2. So it means that 2 can be cancelled out from here. So this can be written as 1 and this can be written as 3. So if you divide numerator and denominator by HCF, it converts into simplest term. So that is what we have to take care of when we are finding out whether any particular expression, rational expression, is in its simplest form or lowest form or not. So let me give you a question. And the question is 6x square minus 5x plus 1 divided by 9x square plus 12x minus 5. Now I need to know whether this is in simplest form or not. If it is not in simplest form, I need to find its lowest form or simplest form. So I am to find whether it is in lowest form or not. Here both numerator and denominators are quadratic equation. So what we need to do over here is we need to find out we need to factorize the quadratic equation in both numerator and denominator. So let me do that for you. So here I can write 6 square minus 3x minus 2x plus 1, and here I can write 9 into 5 is 45 and 15 minus 3 is 45. So I can write that 9x square plus 15x minus 3x minus 5. So let me factorize it for you. This I can write at 3x 2x minus 1 minus 1 2x minus 1, this numerator, and denominator can be written as 3x. So here you find 3x minus 5, and here you can take minus 1, 3x plus 5, sorry, and here you can write 3x plus 5. So what happens here is from numerator here you can write 3x minus 1 into 2x minus 1, and denominator you can write 3x plus 5 multiplied by 3x minus 1. Now in the numerator and denominator you see that 3x minus 1 is common. So what you can do over here is you can cancel out 3x minus 1. So this gives me 2x minus 1 divided by 3x plus 5. This is the lowest form. So that is how you can solve these kind of questions. So to identify whether any rational expression is in lowest term or not, we need to find out that the HCF of numerator and denominator is 1 or not. If HCF of denominator is 1, it means that that is in simplest form or not. And then if it is not in simplest form, then that can be found in simplest term by cancelling the factors properly. Okay, so now let me go to another this thing. So I'll solve a few questions based on addition, subtraction. So let me solve a few questions on addition, subtraction. So if you look at the laws which has been done taken properly in case of addition subtraction. So what happens over here is that suppose px by qx is one of your rational expression and rx by sx is second rational expression. So what you can do is that you can take LCM qx and sx, and this becomes px into sx, and this becomes rx into qx. Now similarly, in case of multiple subtraction, you can take subtraction here, this will turn out to be negative, so I'm writing positive negative both here. Now let me go to different properties of, so if I talk about multiplication, there are different properties involved with multiplications of so first one is closure property. So this tells me that if px by qx multiplied by rx by sx, numerators get multiplied together and denominators get multiplied together. So this is the first property. Associative law tells me that it's associative law will hold true here. Px by qx multiplied by rx by sx, and I take tx by ux. So this can be written as px by qx multiplied by rx by sx, and this can be written as tx by ux. So associative law holds true here. Let me go to cumulative law. So cumulative law also holds true here. So if I change this, just I'm changing this here only, and I change this to, I change this to positive sign here for cumulative law. So what happens over here is I will put a positive sign here, and this will turn out to be, this is px by qx multiplied by rx into sx, and plus you can write px into tx multiplied by qx into ux. This is what you can write in case of cumulative law. Now let me move to another topic. So let me take a few questions over here. Uh, in this case, we should solve a lot of questions. So let me take a few questions. The first question that I'm going to solve is over here is, because there is nothing much except solving questions over here. So you can, I am taking the first question over here, and the first question tells me, and this is a CBSE question. This is x square plus 8x plus 12 divided by x square minus 7x plus 12 multiplied by x square plus 4x minus 12 divided by x square minus 5x plus 4, and I have to write it in simplest form. So this can be written as x plus 6 because all are quadratic equations. So you can just factorize it. This you can write it as x plus 6 x minus 2, and this you can write as x minus 4 x minus 1. Now I'll check whether something is matching or not. So here in case of multiplication, nothing is matching. Now what I do is that if I change this multiplication sign with division sign, now let's see what happens. So if I change this multiplication sign with division sign here, so now let's see what happens. So I can write this as x plus 6 x plus 2 divided by x minus 3 x plus 4 multiplied by x minus 4 x minus 1 divided by x plus 6 x minus 1. So what I can do over here is this x plus 6 and x plus 6 is gone, and once again this is x minus 2. So now what happens is, in the numerator what I get is, in numerator what I'll get is I'll get x plus 2 x plus 4 x minus 1, and is there anything else canceling out? So what cancels out over here is, so in denominator x minus 3 x plus 4 and x minus 2, so you can write x plus 2 x minus 4 x minus 1, and then you can write x minus 3 x plus 4 and x minus 2. This is what the answer would be. Now let me move to another question. And the another question is, suppose I take this question for you guys. So let me take x cube minus 6x square plus 36x divided by x minus 7, and that is divided by x to the power 4 plus 216x. This is a good question. And x square minus 4x minus 21. Now let me solve it one by one. So here numerator x can be taken as outside, and this is x square minus 6x plus 36, and I can write the denominator like x by 7, and I can multiply it, and I can write this x square minus 4x minus 27 is x minus 7x plus 3, and this is nothing but, if you take x common, this comes out to be x cube plus 216, and a cube plus b cube can be sorted out or can be written as a plus b a square minus ab plus b square. So I can write this as x plus 6 x square plus 36 minus 6x. So you can write this as, so this goes in the numerator, so x minus 7 x plus 3 goes in the numerator, and what comes in the denominator is x into x plus 6 x square plus 36 minus 6x. So this x minus 7, x minus 7 is gone. This x and x is gone. This x square minus 6x plus 36 is gone. So what is left out in the numerator is x plus 3, and in the denominator, what is left out is x plus 6. So this is the simplest form that we have been talking about, and this is how it is converted into simplest form. Now let me solve another question for you. So I told that if in the beginning that if simplest form is not asked to you, then what we can do over what we can do in that scenario, or what kind of question can be asked in that scenario. So the first question that is in front of me is x square minus x minus 6 divided by x square minus 9 plus x square plus 2x minus 24 divided by x square minus x minus 12. So here in this question also, what I'll do is first I'll do the factorization, and then I'll do the addition. So this numerator can be written as x minus 3x plus 2. Denominator can be written as x minus 3x plus 3. It is a square minus b square form. So a plus b, a minus b, where a is x and b is 3. And this is nothing but x plus 6, x minus 4, and this is nothing but x minus 4 x plus 3. So here x minus 4 x minus 4 is gone, and here x minus 3 x minus 3 is gone. So what I get is x plus 2 divided by x plus 3, and here I get x plus 6 divided by x plus 3. Now as the denominator is same at both the places, what I can get over here is I can get 2x plus 8 divided by x plus 3. This would be the answer. Now this is also not in a right answer to write, because 2 is common here, so I'll take 2 common here. I'll write 2x plus 4 divided by x plus 3. This is my final answer. Now let me take another question for you. So I take another question, which is 1 divided by x plus a plus 1 divided by x plus b plus 1 divided by x plus c plus ax divided by x square plus ax x cube plus ax square plus bx x cube plus bx square plus cx x cube plus cx square. Now how do you solve this kind of question? So you see here, you find similarity between this particular denominator and this particular denominator. So I'm solving it for one of them. I take 1 by x plus a, and I'm taking ax plus x cube ax square. Now what I do is that I take out from this denominator, I take out x square common. So I have ax in the numerator. I take x square common. I have x plus a as the denominator here. I'll do this later. First, let me show you for this. So what happens over here is this x and this x is gone. Now x plus a is my denominator. So here what I get is x, and here what I get is a. So you see over here that this x plus a is gone. What I get over here is 1 plus x. So similarly in this case also, I can take 1 by x plus b plus bx divided by x. I'm taking common here only, x square I'm taking here common only, and this becomes b, and this x gone. So I can solve 1 by x plus b divided by x into x plus b, and this can be written as x plus b divided by x multiplied by x plus b, x plus b, x plus b gone. So I can write this also as 1 by x. This also can be written as 1 by x plus c, and cx divided by x cube plus cx square can be written as 1 by x. So this answer would be 3 by x. This is your final answer. So if you have some questions like this, you can solve it. Now I have another very good question in front of me, which I would like to solve before I wrap up this session. So you will not get so it is something like this: x square minus y minus z square divided by x plus z square minus y square. Plus, so looking at this question, I can know that what the pattern would be. Here x is there, so now y will come. This y would be replaced by z. This z would be replaced by x. So y square minus z minus x square divided by, now this is x plus y whole square minus z square, and plus this is nothing but z square minus x minus y square divided by y plus z square minus x square. Now how to do this kind of question? Now first look at the numerator. This is something of a square minus b square kind. So this can be written as a minus b, a plus b. So I'm writing x minus y minus z. So this becomes minus, and minus minus will become plus. And the other one would be x plus y minus z divided by, again this is a square minus b square format, so I can write it as x plus z minus y and x plus z plus y. So you see here, this x plus z minus y and x plus z minus y is getting cancelled out. So what I'm getting over here is x plus y minus z divided by x plus y plus z. So I should know that I will get similar kind of term over here. So which will be y minus z plus x, y plus z minus x divided by, I get x plus y minus z and x plus y plus z. Now you look at this term, this x plus y minus z is cancelling this, and what I get over here is y plus z minus x divided by x plus y plus z. Now this also can be written as z minus x plus y, and it can be written as z minus z plus x minus y, and here it can be written as y plus z minus x, and here it can be written as y plus z plus x. So this and this, x plus z minus z plus y minus x get cancelled out, and I get z plus x minus y divided by x plus y plus z. Now my denominator is same everywhere, so I write x plus y plus z. Now you will see 2x are positive here, and 1x is negative. So 2x minus x is x, 2y would be positive here, and here it is negative. So 2y minus y is y, and 2z would be positive here, and here it is negative. So I can write z. So x plus y plus z divided by x plus y plus z will turn into equivalent to 1. So this is what the answer of this question is. Now I have another question for solving, and this question is nothing but 1 divided by 1 minus x plus 1 divided by 1 plus x plus 2 divided by 1 plus x square plus 4 divided by 1 plus x to the power 4. Now this kind of question, I should know that. See what happens over here if I solve this question, this part only. So in the denominator I'll get 1 minus x square, and what is waiting for me to be added is 2 divided by 1 plus x square, where denominator is 1 plus x square. So 1 minus x square and 1 plus x square multiplied together will give me 1 minus x to the power 4, and I have 1 plus x to the power 4. It means that something corresponding is waiting for me always to be added. So I first add this part together, and this gives me a denominator of 1 minus x square. So this will be 1 plus x, and this will be 1 minus x. So this comes out to be 2 divided by 1 minus x square. And now what I'll add over here is 2 divided by 1 plus x square. So what happens is, if I take 2 common, this gives me 1 plus x square plus 1 minus x square divided by 1 minus x to the power 4. And again this x square is gone. So what is left out is 1 plus 1, 2, 2 into 2, 4, 4 divided by 1 minus x to the power 4, and which I add here. So 4 divided by 1 minus x to the power 4, 4 divided by 1 plus x to the power 4. So I have 1 minus x to the power 8, and I take 4 common here. So this becomes 1 plus x to the power 4 plus 1 minus x to the power 4. This and this is gone. So 4 into 2 is how much? 8 divided by 1 minus x to the power 8. So the answer is 8 divided by 1 minus x to the power 8. And this is how this question can be solved. So looking at the pattern in these kind of questions is very, very important. If you are not able to find out pattern, generally if you look at all the questions which has appeared in your examination, would be some kind of pattern. So some kind of pattern would be available in that kind of in that question. It will be better if you look at the pattern and then try to solve the question. Like in the last question, looking at the denominator, I could identify the pattern, that the pattern was 1 minus x, 1 plus x, which turns into 1 minus x square. Then 1 minus x square multiplied by 1 plus x square gives me 1 plus x to the 1 minus x to the power 4, which can be multiplied to 1 plus x to the power 4, and I can get similar values over there. So this is how you had to solve the question. Now look at here, another question to be solved is 1 divided by x minus 2, x minus 3 plus 1 divided by x minus 2, x minus 1 plus 2 divided by x minus 3, x minus 5. Now what I do over here is I take x minus 2 common. So I take 1 divided by x minus 2 common. What left out with me is 1 divided by x minus 3 divided by x minus 1. And I'll write it as it is over here. So this gives me 1 divided by x minus 2. And this is nothing but x minus 1 plus x minus 3 divided by x minus 1 multiplied by x minus 3. Now let's solve it here. This will be nothing but 1 divided by, and 2x minus 4 is nothing but you take 2 common. This will be 2 multiplied by x minus 2, x minus 1, x minus 3. So x minus 2 gets cancelled over here, and what I get from here is 2 divided by x minus 1, x minus 3. Now I'll add this to 2 divided by x minus 3, x minus 5. So here also you can see in the denominator x minus 3 and x minus 3 is equal. So I take 2 divided by x minus 3 common, and what is left out is x minus 1 plus x minus 5, and this is equal to 2 divided by x minus 3, and this is x minus 1 plus x minus 5 divided by x minus 1 multiplied by x minus 5. So this is equal to 2 divided by x minus 3, and this is 2x minus 6 divided by x minus 1, x minus 5. So this is nothing but 2 multiplied by 2 taken from there, and this is x minus 3 here, and this x minus 3, x minus 1, x minus 5 will remain as it is. This and this gone. So my answer would be 4 divided by x minus 1, x minus 5. As simple as that. And you cannot leave it like this. So you multiply it and then you write 4 divided by x square minus 6x plus 5. So this is your final answer. So this is what I had to teach in this session. So I am wrapping up the session by saying that both these topics are very scoring in maths. So you should focus a lot on this. In algebraic expression, just try to look at the pattern, which pattern needs to be followed, how the pattern is coming from solving the questions. uh, I mean, if matrix is to be talked about, in matrix a lot of people tend to make a lot of numerical, I mean, calculation mistakes, careless mistakes. Please be aware when you are multiplying two numbers, adding two numbers, subtracting two numbers, because what happens is if your calculation is right, there is nothing which cannot be solved in that in these two topics. So especially matrix, because you don't have anything apart from subtraction, addition and multiplication. So please focus on calculation errors. I mean, it, you should not make too many calculation errors. Also at the very same time, what happens is if you practice more questions, with time those calculation errors will keep on going down. So practice a lot of matrix question, try to eliminate your calculation errors. In algebraic expressions, try to identify the pattern. If you identify the pattern, you can solve the questions uh, quickly. So that's all from me today. Thank you so much for attending this class and hope we'll meet soon. Thank you so much.